Welcome to Mastering Machines, where we discover tomorrow's reality.
Hey everyone, remember when the Transformer architecture paper revolutionized AI back in 2017? For all of you that don't know, the Transformer architecture paper was a pivotal paper for the AI industry, and it was created by Google, and it was basically a structure that talked about how attention is all you need for these AI models to become better. The transformer architecture is based off of an encoder-decoder structure. The encoder processes input sequences through multiple layers of self-attention and feed-forward networks, creating contextualized representations, and the decoder then generates output sequences using these representations and its own self-attention mechanisms. Remember that the most transformative AI model, ChatGPT, is based off of the Transformer architecture, and GPT actually stands for Generative Pre-trained Transformer. Now, Google has released another revolutionary and groundbreaking AI architecture paper that's called Titans, and a lot of researchers in the AI field believe that this will change a lot of different elements of how AI systems process and remember information. Let's break down why Titans is so revolutionary. It introduces three game-changing components to the architecture of AI models. One being the core memory. Think of this as the model's working memory, using attention mechanisms but with a limited window size. This makes it incredibly efficient compared to traditional transformers. Two, there's going to be the long-term neural memory. This is where things get really interesting in the paper. Unlike traditional models that compress information into fixed size rates, Titans uses a deep neural network that actively learns how to memorize information at test time. It's particularly clever because it focuses more on surprising information. It uses a momentum-based system to track information flow. It also can actually forget irrelevant information just like human memory. And number three, the persistent memory. A set of learnable but data-independent parameters that encode task-specific knowledge. The results of this have really been staggering. In tests, Titans outperformed every modern recurrent model and transformer variant. So let's look at some of these numbers. It achieved perplexity scores of 18.61 on wiki testing. It reached accuracy rates of 70.46% on PIQA tasks. And PIQA is basically a data set for common sense reasoning. It handled sequences longer than 2 million tokens effectively. And most importantly, it did this while being more computationally efficient. And I want to specifically talk about why this might be as significant as the original Transformer paper. One being the memory management revolution. So traditional transformers use quadratic attention mechanisms. Current recurrent models compress everything into fixed states. Titans introduces a completely new way of handling memory that's both more efficient and more effective. Also, they'll have scalability breakthrough. While transformers struggle with context length behind a certain point, Titans can handle sequences over that 2 million tokens long area that I was talking about earlier. And it does this while maintaining and improving the accuracy. And then also the efficiency innovation. The model achieves an 84% decrease in research expenses compared to previous methods. It can complete entire research projects for just $2.33 using GPT-4. Also, this makes it incredibly accessible for not only just researchers, but also regular developers as well. The implications of this particular model could be enormous. So think about this. Research assistants that can actually remember and reference entire papers. AI systems that can maintain context over extremely long conversations, more than even the AI models that we have out currently. There'll be models that can process entire books while maintaining the understanding of that book and the context of that book. Also, there's going to be systems that can learn and adapt during use and not just during training. What makes Titans particularly game-changing is its memory architecture that I've talked about earlier. It uses three different variants: memory as context, memory as gate, and memory as layer. Each variant offers different trade-offs between efficiency and effectiveness. The system can actively learn to memorize at test time, something most models can't do, and it also is kind of akin to like a human. In comparison to the Transformers era, just like how Transformers solved the long-range dependency problem in 2017, Titan solves the long context memory problem in 2024. And just like Transformers, it does this in an elegant way that's both more efficient and more effective than previous approaches. If more models use this architecture in the future, it will be a fundamental shift in how AI systems handle memory. It'll be more efficient, accessible AI research tools, systems that can truly learn and adapt in real time, and it will essentially create a new foundation for the next generation of AI models and how they're operated. The researchers behind Titans hope this will accelerate scientific discovery by allowing AI to be better research assistants. And given the results, we're seeing that they might be right regarding this. This could be the beginning of a new era in AI, just like Transformers was in 2017. Let me know in the comments what you think. Do you think the Titans architecture could be the next paradigm shift in AI? And how would you use this in terms of a memory capability? Let me know. And remember, master machines discover tomorrow's reality.